we do get the post-condition violations we expected, right? So now the whole purpose of the lecture is really to demonstrate to you that if your post-condition is too weak, it might allow something that's bad to just get away with that. So you do expect some contra-violation to occur in this case, because if you do have the wrong implementation there, so your post-condition will be able to capture that, okay? So now, but we don't simply let a red plot. That's not good. So let's say, imagine that we only have the last version there, okay? Forget about the previous form, okay? Imagine they are not there. We only have that, but now we have a post-condition violation. But now we simply want to have a test case where we want to make sure the post-condition we have is not too weak or strong. When we say something that's incomplete, we really mean it is too weak, because it doesn't really cover enough aspects to consider, right? So that's too weak. So in this case, we want some test case to make sure our post-condition is not too weak. In this case, in the test case, we're actually going to give something that's invalid, and we want to make sure some counter-violation will be caused as expected. In this case, the ES test, remember we actually have different features we can use. So we have, so actually I think one of the study guide actually tells you how to, actually ask you how to do such cases. For example, in the post condition, how do you make sure the post condition is not too weak? How to embed that in the test case? So you have the bad violation case, and then here you have two variants of that. Either you say add violation case, or you can say add violation case with tag. Okay, in this case, for example, we can make the final post condition there, we can give it a name of tag. So what we can do is, so here, let's say we give this post condition a tag, let's say the rest not changed, for example. Okay, so give a name and then colon. So here you can say, of course, you can say the rest unchanged. Okay, so as I said before, you don't have to worry about agents now, but you do have to put it. I'll talk about agents maybe after the picture. Agents, and then here we actually put the test feature here. Okay, we say, for example, test. Post-condition not too weak. This is how you add it to the ES test case. Okay, with tag. Okay, that's something you have to know. Let's say in a similar case, let's say I want to make sure if I pass some illegal value to the feature call, and I do expect some precondition to be violated. In this case, of course, I also have to use the add violation case with tag. And the feature I pass here, in this case, would be simply a command. So you should execute as normal without any return type, but I do expect something, some counter violation to actually occur in the middle. Okay? If you are not sure about that, please refer back to the tutorial video. I did talk about this in very much detail. Okay, that's also very important stuff for the return. You really know what I meant, right? Okay.
Difficult.
Yeah?
It's
no?
difficult.
That's, well, that's, okay. Okay, we have to know when to use Boolean case, when to use add a violation case.
Oh, yes.
So that's actually the coverage for the return. So now I'm going to start a new lecture, which we'll be covering in the later test. And maybe today you can start forming your study group. Maybe you have done that already during the break. So I can start helping each other. Okay, so now we're going to talk about something called inheritance and polymorphism. And I believe many of the concepts you already learned that from the Java course. But something that's really unique about IFO is, so because in IFO, we actually have contracts. So the most important messages for you to get by the end of the lecture is to see how the inheritance is going to affect the contracts between superclass and subclass. That's the most important question to understand for the lecture. Okay? And otherwise, with inheritance polymorphism, you already know that from Java. There's no unique thing here about IFO. What's really unique about IFO is how the contracts are defined between a superclass and a subclass. That's the important stuff to understand. Okay, so now we have some problem here. So now remember I said before, somehow we want to make sure once you have defined your interface, you have to make sure your interface stays stable. Otherwise, any clients who depend on your interface may suddenly just have their code uncompilable. Okay, for example, let's say you have a class here. So you have your supplier class. And by the way, I'm drawing some Venn diagram for you, so I make sure you also know how to draw that. So that's effective. And so here we have some client-supplier relationship. Double error here, and we have some client here. Okay, so now this client depends on this supplier. Okay, and the client is also effective. So now, let's say the supplier side, let's say we have F, and let's say we have G, and we have H, for example, with the different features. And let's say F, F, G, and H. So now, let's say somehow we actually want to get some new, let's say if you want to get new features. Okay, let's make another new feature. Let's say we want to somehow change the behavior of one of the features. Okay, that's it later on. Because when you're developing the software, this actually never can end. You always have to keep developing the software for the new needs of your customers. So let's say if somehow we want to change the behavior of this feature here. And certainly, if we do that, it's going to affect, let's say we do have some code here where the client is trying to use that over here. If you change that, it's going to affect the clients, although the interface hasn't changed. But if you change the behavior of that, it's going to change that. Okay? Let's say we have client. Let's say we have client 1, client 2. Let's say somehow the intention is somehow client 2 actually does want the new version of F. However, this new client, this old client here may not like the new definition too much, but somehow you want to satisfy them both. You see the issue here? Okay, so this is the old client who actually depends on F, but now suddenly it comes a new client who actually wants some new services on F. But now, if you actually somehow change the behavior of F, client 2 might be happy, but client 1 wouldn't be. So somehow you have that dilemma here, right? So that's sort of the issue we are dealing with. Let's have a look at the slides. So now, okay, so let's say we have A here. A is the supplier of B, B, C, and also you can see that indirectly, E is also the client of A. Because you can see E is a client of C, and C is a client of A. So somehow it's indirect. Okay, either indirect or direct. So A, the existing implementation for A has so many clients here. So now, our problem is we want to define some new features or new functionalities for A.
So
okay?
this means if C is the supplier of E.
C is the supplier of E. Yeah.
Is right?
That's right. Because the arrow here, you can see the arrow head here is points to the supplier.
Oh.
A is the supplier of B, A is the supplier of C. And indirectly, A is also the supplier of E, indirectly.
Oh.
All right? Okay, so now, solution 1. Simply just modify A. Okay, that's not good because you modify A to satisfy the new clients, but you might disappoint your existing clients. Okay, that's not good. Solution B, create a new copy of A such that you actually somehow do the new functionality that the new client is requesting. So that means we have now, let's say F, G, H, and I. They're simply some other new clients. They actually simply want a new functionality of A. So that's why we say A and A prime. So A prime is like a variance of A. So now we have two, basically A and A prime. They actually overlap very much. Maybe just a few differences on the features. Okay. Now problems. Okay. Now directly tell you what the problems are. Okay, problems. So now for the first one. So here you can see that it's actually exactly what I said. So now you can see that if you simply just modify A, okay, so for A, so let's say, have a look at this. So let's say this is the old clients, this is the new clients. And let's say somehow the new client here want a completely different behavior for F, G, and H. And maybe some completely different precondition and postcondition. In that case, if you satisfy that, you might disappoint that. You cannot really satisfy them both, right? So if you simply just change this directly, then it's very likely you cannot satisfy both. So that's a problem. So you can see inconsistent assumptions and guarantee. So let's say if you used to guarantee to the old clients something that might just be changed in order to satisfy the new clients. So now you've got some inconsistency here. So me, if I'm the old client, I'll be very unhappy. Okay? Let's have some example here. Let's say if this supplier here, let's say some supplier of some smartphone, okay? If there's some notification function there, okay, me as a client, I expect a notification to actually give me maybe the reminder of today. And another new client there, for some reason, he will write the reminder for not today, but tomorrow. So now we have inconsistency here. So if the smartphone company simply changes the existing behavior for the notification function to always give me the reminder for tomorrow, which is not what I really expect to do, what I really expect to see. But that will be a problem, right? We have some inconsistent expectations here. We'll see a more concrete example later for the smartphone. Okay, now, that's the problem for the first one. If you simply just modify the original module or the class. Now for the second solution here, if you simply just create a copy of A, which looks almost exactly the same, but you just modify something there. So now the problem is, let's say, as you actually have new clients, each one of them actually requires something a little bit different from the existing variants. You just have to keep creating the variants. And the problem is, every time when you create a new class or a new module, what do you have to do? You have to run test cases. So that's expensive to actually retest on your new classes. Okay? And you have to write new test cases for the functions. So that's really inefficient and not really maintainable. Okay, so you can see that we actually have two possible solutions to this problem here. So we can see the drawbacks for both of them. So now, what we're really talking about is we want to make the modules or the classes both being open and closed. Open in the sense that it should be open to actually to accept new functionalities from the new requests. It should be closed in the sense that it shouldn't really affect the existing customers who already depend on your old version of the features. Okay, open and closed. Okay, so this is actually the so-called open-close principle. Actually, it sounds contradictory, isn't it? Because you want something to be both open and closed. It doesn't seem to be very possible. Okay? So, that's exactly what I said. So you want to, it should be open because always, you will always get new requests from customers because you cannot really just implement all the possible extensions in one go. It's not possible. Okay, so now closed, if to make sure the API is stable and the behavior is also consistent, that's also something difficult to do. Okay, closed, and that has something to do with information hiding. Yeah, so I remember Chris, you actually mentioned about the open-close principle in our first lecture. So this is how the two things are related. Okay, they're related to the closed part. Yeah. Okay, so now information hiding, so we want to make sure it is closed in the sense that if the supplier changes their internal behavior, it shouldn't cause any surprise to you as a client. Okay? So now, that's contradiction. So now, to actually solve this problem, we have to talk about inheritance. Okay? And now, for the inheritance, maybe what you learned from Java was, when you do inheritance, it has basically two purposes. The first one is to classify your entities. For example, you might have, let's say, you have a classification for person here. Let's put, for the entities into different categories. So now you might say a person might be a student, okay? Or they might be a faculty, or maybe they might also be a TA, for example. Yeah, so you actually got different categories of persons in this case. You're trying to partition the person into different categories, okay? Yeah, it's like a fancy word, taxonomy. It's like about defining categories of your entities. Okay, classification, that's why we call it classes, right? It's a particular class of entities, that's why we call it classes. Okay, also reuse of code, because in your Java class, whenever you say one class extends from another, you can actually reuse the code from your parent class or your superclass. That's about code reuse. However, what's really nice about iPhone is, since iPhone supports the idea of assignment contracts, so there's something called substitutability. Okay, let me give you a very quick example for now. Let me see if I have it. Use our smartphone idea. Okay, smartphone, and then let's say we have two possible brands. Either it's an iPhone, or it's let's say Samsung. Okay, so let's say this. Let's say this is deferred. So these are effective. Okay. Now, basically, it corresponds to what you learned from Java. I just want to show you how the idea of substitutability might be related to contracts in iPhone. So now, let's say, if you declare some variable here, phone. Okay, so declaration here, not defining yet. Phone is of type smartphone. Okay, so now you also have, let's say, iPhone. Okay, and now you also have Samsung. Okay, so we have three variable declarations. Let's say somehow you do some initialization there. Okay, so now let me just put it here. So now let's consider if I say phone, my phone initially is actually an iPhone. Okay, so now I can say phone. Now it changes to Samsung. First of all, if I simply have these two lines, would it compile? Yeah. They would, right? Because we're trying to assign something that's more specific to something that's more general. Agree? So that means, so what does that really mean? So now I simply just want a smartphone. It doesn't matter if you give me an iPhone or a Samsung, as long as they're both smartphones. So somehow I can substitute a Samsung for iPhone in this case. That's what really these two assignments mean. Now what I really mean by substitute, that means as far as the features that are actually defined in this smartphone are concerned. Somehow, let's say we have one feature, let's say notification. I'll give you more details in later slides. There's a notification here. Okay, notification here. So I wouldn't mind if you actually go from iPhone into Samsung, as long as the notification feature they support there is consistent with what's defined in smartphone. Okay, because when I say I want a phone, I simply say it's a smartphone. So as long as the behavior is consistent with the smartphone unpacking, doesn't matter if you use the iPhone or Samsung, they are substitutable. Okay, let me change the code a little bit. What happens if I say I change this to, let's say, iPhone? So now tell me which line we compile.
The second one.
Second one, agree? So now this one, okay, I expect an iPhone, and you do give me an iPhone, that's great. But now I expect an iPhone, you give me Samsung, although it is also a smartphone. Right? In some way, this is not substitutable. Because there might be some features they're actually supporting Samsung that wouldn't actually satisfy me, who actually want to use an iPhone. Okay, I'm just trying to show you that's sort of the interpretation we should really have from this kind of assignment, why they are invalid or why they are valid. When you can actually change from one to another, that means the objects, somehow they should be substitutable. But when the assignment is actually not valid, that means they are not substitutable.
Sure.
And whether they are substitutable or not depends on the hierarchy, like the class diagram, the inheritance diagram we have here. You simply can assign this to something like that. So if you are expecting this, you can substitute between any descending classes, any child classes. But now, if I am expecting something here, you simply cannot give me something that's kind of irrelevant. Okay? But one thing is, how do we actually make sure such substitutability constraints can be also checked at runtime? Okay? That means, let's say now, let me just change this back to smartphone. Okay? So now we're talking beyond compilation time. So now let's say this is again still smartphone. So now we have phone is assigned to be iPhone and phone is assigned to be Samsung. So now they are substitutable because both assignments are valid. But now, how do you actually check that the feature that I actually got from iPhone is consistent with the feature I got from Samsung? How do I check that? In Java, there's no way to check that because once you pass the compiler checks, nothing else will be done for you. However, in iPhone, remember, we actually have the pre and post conditions. And at the runtime, somehow iPhone runtime is actually going to check to see there must be some constraints that actually define as contracts at the smartphone level. So now, as you're using the iPhone objects, those contracts will be checked as you're using the iPhone. And the same set of contracts will also be checked when using a Samsung phone to make sure you have some basic guarantee. That's a big picture, and we will actually go into more details later. Okay, so what you really want to know is, this assignment here, nothing new, just the same as Java before, but now what you really want to know, want to make sure is, since we can do the two assignments between two subclasses, two subclass instances, so we're saying these two things are substitutable. Okay, this is a keyword of today, basically. Actually, that's a keyword for this particular lecture. Okay, when we say it is substitutable, we really want to make sure we can check at the runtime. Okay, and there's no way to check this in Java by default. However, in iPhone it is possible because we got contracts. Okay, we'll see more examples actually. I'll actually give you more concrete example as to see how the precondition and postcondition of notification might be, and what would be the violation case for that. Okay, did you have a question?
Yes.
Substitutable only concerned about public features. But for the private ones, because they are not visible in the contract view, so they are not of our concern.
Oh.
However, if somehow the private features affect the behavior of the public features somehow, then you have to worry. Okay? Okay, that's a good concern actually. So substitutable only worry about the interface of your parent class and child classes that is really have to do with contracts. So now, in the Java classes you took before, in the Java context, you inherit the code. In iPhone, you do inherit the code, but you also inherit the contracts. That's really the crucial difference. We're going to see examples now. Okay, so nothing too difficult so far. So that's, again, the original problem here. So we want to actually make sure so A and A prime, so now inheritance will be the solution to that. So somehow we want to say you have A prime. If you use inheritance, we're trying to say somehow if you want to use A for the new old clients, or you also have A prime for the new clients. But you can actually have some guarantee that A and A prime are somehow consistent with each other. We'll actually see what that means. Okay, open-close principle. Open in the sense that you can extend, closed in the sense that the interface is stable. Okay, so now we actually have inheritance. So actually, I'm sure you learned about this. You know, the inheritance is about extension and specialization. So now, the fact that we have the iPhone or Samsung as an extension of smartphone because they may have some specialized properties or some specialized feature. For example, you might in a smartphone you may not have a iTunes feature, right? But in an iPhone, they do have some specialized features that are specific to iTunes. And for Samsung, I'm not sure, but I'm sure you can find some. Okay, that's the idea. So this slide is a little bit theoretical, but again, you have to know the difference between module and type. So module is really about the static compile time thing. It's like a classes you have. And the type is really about dynamic and runtime, like objects. Okay, so for inheritance, now actually you want to say let's just do this example here. So what we're trying to say is, if iPhone inherits from smartphone, so that means all the features we define for smartphone must be supported in iPhone as inheritance, right? And now, from the type point of view, one more thing. So let's say you have a notification feature. So this notification feature must be also supported in iPhone. However, the way iPhone defines this implementation for notification might be like a supply secrets from Apple. So you actually have no idea how they redefine the implementation for notification, right? So it's a secret. Yeah. Okay, now for type. Okay, so what we're trying to say is, so at the runtime, you have a number of iPhone instances, and whenever you're expecting some smartphone instance, you can just give me an iPhone instance, because iPhone is a smartphone. Okay, nothing new. Okay, so just some terminology. This slide is a little boring, but basically you just have the base class. Base class is important though. So now let me just make this better. I don't want to cross it. Smartphone. So this class here is set to be the base class. Okay? So now, when you are doing this assignment here, when they actually compile the code, you're actually going to see what's the base class for this variable here. Because in this case, its base class is smartphone, right? And now, for iPhone, its base class is iPhone, right? So, to actually determine to see if this assignment is valid or not, it's actually going to check the class hierarchy. So if you're trying to assign something from here to something there, you will be valid in terms of base classes. However, if you're trying to do the other way around, let's say you're trying to assign some smartphone into iPhone, that'll be not okay. Or if you're trying to assign some Samsung to some iPhone, that would not be okay either. So the idea about base classes is really important. So base class is really the class that you mentioned in the declaration type. Okay?
This declaration type means compile type.
But at the runtime, you might assign different bindings to the type, right? I'm sure you heard about bindings before. We'll talk about that. Okay, base classes. So you have superclass, subclass. Also, you have parents, heir. Also, ancestors. So basically, you can see that. So actually, let's say iPhone. Let's say somewhere down off the hierarchy here, you also have the class of phone. Okay, so smartphones and proper ancestors. This is actually similar to the notion between proper subset and subset, right? So in the logic course, when you say I have S1 is a subset of S2 versus this one here, and also we have also instances. It's really about runtime type. So you can just go over the slides. Okay, now this comes the important parts. So now we have polymorphism and dynamic binding, which are not really new to you because you learned that also from the Java course, right? So now, just like a recap, well, we're going to say how that works in iPhone, which is consistent with how it works in Java. So polymorphism, which means an object might change its shape at the runtime. That means at the runtime, a phone might actually go from iPhone to Samsung, right? That's polymorphism because it can assign objects of different classes to the same objects, to the same object reference, provided that those two base classes are the subclasses of that base class. Okay, that's the idea. And now for dynamic binding, it's actually to say what kind of services, what kind of feature behavior you will get at the runtime depends on the current shape of that object. Because you know that your phone actually can change its shape from iPhone into Samsung. So if you actually try to call, let's say phone dot, I don't know, how would you say, let's say get music player, let's say. For example. Okay, here you can also say phone. You know what? You can either say music player or get browser. I think that might be easier to see. If you say phone dot get either music player or browser. Okay, now because now in this line here and in this line here, we are changing the shape of the smartphone from iPhone into Samsung. So now so the current shape of this phone is actually iPhone. So when you actually say get music player, you get iTunes. Or you might get, you say get browser with Safari. Right? Now, if you actually say phone, now changes shape into Samsung, like an Android phone, basically. So now you say get music player, I don't know, I haven't used Android phone before. Maybe you say get browser, like get Chrome, or you may get Firefox, etc. But you see my idea, right? Okay, so I think that this slide actually actually summarizes the difference between how the polymorphism and dynamic binding are related. Okay, again, as a recap. Polymorphism makes sure your objects might be attached to different runtime objects, like you pointing to. And dynamic binding makes sure, depending on what the current objects that your reference is attached to, you will actually call the correct version of the services of the feature. Okay? Any questions? Yes.
Are they the same thing, like dynamic binding and polymorphism, or is it?
They are not the same thing, but they are related. So polymorphism means you can change the shape. And the dynamic binding means that since you can change your shape, so the surfaces you will get depends on the current shape. They are related. We talk about binding here. So let's say now, by the structure. So let's say initially I assign my phone to some, let's say Samsung, there's an object here. And somewhere in the object it has the definition for the, let's say, get browser feature. So now, if I somehow say phone is now assigned to some Samsung, so now for the same kind of feature there, it has a different definition for the feature. So now if I say, now phone should be attached to Samsung here, you actually make sure, when I say phone, let's say get right browser, it's going to call this version of the feature, but nothing else. Okay? We'll see more example in the slides later. Slide problem. Okay. So, do you want a 5 minutes break, and then we'll go until maybe 10 to 10? Okay, how about that? 5 minutes break.